Alright, so this time we're going to look at a different type of relationship that's occurring in an ecosystem than just competition. We're going to start off with setting it up like this, but then we're going to add some things to it. So again, we're just going to watch the video and follow along with me. The first thing I'm going to do is I'm going to add these two plants in, then move ahead to day 5. Okay. So again, we're kind of saying that fires took place, wiping out the ecosystem, and we're going to introduce 2 new species to the ecosystem, okay, which is going to be plant B and C. And I'm just going to go ahead 5 days. You're then going to add 1 more species to it, in this case herbivore B, which eats plant B. Again, I'm going to go ahead 5 days. It eats plant B. We're at day 5, and we're going to move ahead 5 days. Okay, so as you can see there, as soon as we added in that other plant, that other organism, that herbivore, we have an herbivore autotroph relationship, okay, between, of course, here, herbivore B and plant B. So this is because, of course, the herbivore is feeding upon the plant for energy, which, of course, is a biotic factor. The population of herbivore B is going to increase substantially here from day 5, when it was first introduced into the ecosystem, to basically right day 9, then day 10 it starts to level off a little bit. Okay, whereas the other one, plant B, well, as soon as it enters the ecosystem, this is the only thing it's eating, so its population is going to go down because, of course, it's being eaten or grazed upon by the snail. Now, herbivore B and plant C, the thing about these two is that this is not eating that. So this is not an autotroph herbivore relationship. So instead we have what is called a symbiotic relationship. Well, that's because, of course, this is not eating it. So if you look at the population of plant C, it's being positively affected by that. So it likes the snail here. Whereas, really, the snail is unaffected by this plant. That's a symbiotic relationship, which is called commensalism, where one is positively affected, plant C, but it really doesn't affect this herbivore. The only thing affecting this herbivore, snail, is the fact that it's eating plant B. That's commensalism, symbiotic relationship. And so the reason why this population of plant C is increasing is because its competition, which is plant B, is being eaten. Well, that's good for plant C here. If this is being eaten, then now this plant has more resources. It's got more space to grow, okay, because they're competing for the same soil nutrients, they're competing for sunlight, all those things that plants are going to compete for. Well, now, dominant autotroph really was plant B, as you can kind of see in the beginning. Plant B was the dominant autotroph, okay, but because of this herbivore coming in, it's really leveling that playing field. Really, the dominant autotroph still is plant B if they're just competing 1-to-1. All right, that's really the end of part 1, which covers up to right here. So if you need to pause the video to get the first 7 questions done, do so. But I'm going to skip ahead now to part 2, which is going to move all the way until day number 70. So here we are at day 10. We're going to skip ahead to day 70 and watch what happens. So as you can kind of see, our populations are fluctuating a lot, all three organisms, herbivore B, plant B, as well as plant C. So these things, as when a new species is introduced into an ecosystem, affects every single species in that ecosystem, which right now is only 3, but things are going to fluctuate a lot in the beginning, and then you can kind of see they're starting to settle off a little bit here as we move ahead. So they're still fluctuating, just not as much, until finally we start to level off a little bit. Okay, so there's day number 70. All right, so that's really the end of part 2, which is really just understanding that things fluctuate. So part 3 then, we're going to add now 5 more days to it when another species enters the ecosystem. Okay, this one is only going to eat plant C this time. All right, so I'm going to go over to simulation. So we have this deer, which is herbivore C, which is going to eat only plant C. And again, we're going to move ahead now 5 days and see what happens. Okay, so now we're ahead 5 days. So notice that herbivore C eats only plant C. Well, that's the competition of plant B. So if its competition, its population is obviously going to go down because it's being eaten, well, that's good for this population. So you would expect that the population this is going to go up, which is what we see happening right here. We see a slight upward tick. So plant C's population is going to go up because its competition's population, plant C, is going down. It now has more abiotic resources because, again, these are in competition for soil nutrients and so on. Now this has more nutrients, more resources than it had before, so its population is going to go up. In contrast, of course, plant C's population is going to go down because it's being grazed upon now, where it wasn't before, by herbivore C. Herbivore C's population is going to go up because, of course, it has a lot of food now. Herbivore B, which is right here, its population is also going to go up because its food source, remember this plant B went up because its competition went down, but now there's more of this, meaning the snail now has a greater food source, so its population is now going to go up, and so we see it going up. Okay, so that kind of finishes us off, even though I don't go over every question in order, up through part 4, which is question 12. Play the other video that I have linked in here for today. That will do the rest of this worksheet.